Welcome. Let's look at exponents, and let's start with the exponent of 0. Anything raised to the 0 power is equal to 1. Anything. Here are examples of larger numbers, smaller numbers, a variable. If it's inside parentheses, this entire thing is raised to the power of 0. This entire thing is raised to the power of 0. It's 1. Here's a little proof as to why that's true. Let's take any variable raised to any power, say 12. And let's put underneath it x to the 12th. That's equal to 1. What we're going to do in this section is go over about negative exponents. And in this case, what that means is you can take this x to the 12th and you can move it to the top part of the fraction as long as you change the sign. So what we now get is x to the 12th minus 12, which is equal to x to the 0. Except that we know that this x to the 12th is equal to 1, and it's also equal to x to the 0. Therefore, x to the 0 is equal to 1. Anything to the 0 could be that. This could be 852, and this could be 852. As long as they're the same, when you bring it up to a negative exponent, then you get 0 for the power, and that means it's equal to 1. Now, these three problems are a little different than the 5 above it because of the fact that this 5 has an exponent of 1. It is not inside the parentheses. Therefore, it is 5 times 1. X to the 7th to 0 is equal to 1. That means the answer to this one is 5. And in the same way, all of this is raised to the power of 0. But the 94 is not raised to the power of 0. Therefore, it's the 94 times 1. And over here, only the z to the 49th power is raised to a 2. The x to the 5th is not raised to anything. Of course, the 94 has a power of 1. So what happens here is only this thing is a 1. So we actually have 94x to the 5th z to the 98th power, and I'll put that here as the answer. So these are the only ones that are sort of unusual, and they're not really unusual. It's more just getting used to the fact that not everything has a power of 0. So the coefficients that are outside parentheses do not. Now let's look at the concept for simplifying these. And everything runs off of 12 over 9 concept. 12 is actually equal to 3 times 4, and 9 is equal to 3 times 3, so the 3's cancel, which means 12 over 9 is the same as 4 over 3. On this one, what's happening is that we have 9 x's, and underneath it, 2 x's. Well, this x cancels out with one of the ones on top, and this x cancels out with one of the ones on top. So we are left with x to the 7th power. It's much easier just simply to do 9 minus 2. So the ones on top subtract the ones on bottom. And conceptually, it's simply that there's more x's on top than there are on the bottom. So the ones on the bottom cancel out some of the ones on top. If it's on the bottom, that's perfectly fine too. We have 2 on top, and we have 9 of them on the bottom. So this one cancels that one, this one cancels that one. And so now we have 7 of them on the bottom. And on the top, remember, there's always a 1 in front of everything. So that means that 1 is still there. And we don't usually show it because we don't need to, but we do need to here. So remember, if you have more x's on the bottom, then you're going to have x's on the bottom for your answer there. Right? Sometimes people do this one like this, but they just can't get the concept that you can have an answer that only has x's on the bottom and not on top. So that's a concept you need to have to be able to get these correct. And just sort of keeping track in your mind what's in the numerator and what's in the denominator. Now we're going to do it with a couple of different things. So here we have x's, and we have more x's on top than on the bottom, to the point where there's only 1 x on top. And then we have these y's, where we see that there are y's on the top 5 of them more than on the bottom. So those 2 on the bottom cancel out 2 on top. So that means our answer is, and I'm going to make the x blue this time, y to the 5th. Okay. Next one, now we have a combination where we'll have some on the bottom and some on top. So let's start with the x's, and we see that there's 9 on top and 5 on the bottom. So these 5 on the bottom will subtract from the 9. Okay? We'll take away because there's more x's on top. In fact, there are 4 x's on top that are not canceled out. But then we look at the y's, and there's 11 on the bottom and 5 on top, so 11 take away 5 is 6. Because those 5 cancel out 5 of the ones on the bottom. This is the kind of conceptual thinking I want you to do with each of these types, so you don't get mixed up as to what's there, what's left. So now let's take a look at these x's. Here, the x's, there's 2 more on the bottom than there are on top. So I'm going to put x squared on the bottom. And when I look at the y's, well, there's more y's on bottom than on the top. In fact, there's 4 more. So 5 on top will cancel out some of the ones on the bottom. And there's nothing left on top except, don't forget, there's that automatic always 1 that's there, because it's 1 times x cubed times y to the 5th. We just don't show the 1 unless we have to when there's nothing else on top. Now on the next one, x cubed over x cubed, well, that's equal to just 1. So that just cancels itself out. Here, there are 5 of these y's, and that cancels out all but 1 of those. So there's a y on the bottom, and the one that's a coefficient on top stays on top. Seems sort of a simpler one, but especially once you recognize the cancel out that. So let's review what happened with these. All right, simple canceling out of a common factor for both. And that's what we have here. We have common factors, common numbers, and we cancel those out, and there's 7 left. But that's on top. This one was on top. This one was on bottom. This one was 2 variables, both on top. 2 variables where one's on top and one's on bottom. Here, both variables are on bottom. And here, one variable just cancels out. So there are all these different ways you can see it, but they all follow the same rule of canceling out extras, so that you have them only on top or only on bottom, whichever particular one, and you just subtract. Now, all these practice ones next to them are very similar to these. Why don't you take a moment to pause the video, do all of these practice ones, and then turn the video back on, and you can, and then I'll go through each one. I'll go through the answers for them. All right, welcome back. Now let me write down the answers for each one of these. So if you've gotten them correct, then you will know it. And if you have them wrong, you can look back at them and see, think about how I figured out that particular one. Equals y over x to the 3rd power. And c is y to the 16th over x. And d is equal to x to the 7th over y to the 7th. E is equal to x to the 9th. And f is equal to y over x. So if you had all of these correct, wonderful. If you didn't, then think about where your error was in your thinking or your writing so that you don't repeat that error. And then you will feel really good about doing these on any test or exam, or using them in other things in the future. Let's look at this one where it's a combined problem where there is an inside part, the other way, this inside part, and you'll have to do that first before you apply this exponent of 3. The reason we do that is PEMDAS. So you do the parentheses first, which are actually, instead of parentheses, that's not broad enough. Grouping symbols is what you look for. And the division line is actually itself a grouping symbol. It's saying take the stuff on top and divide it by the stuff on bottom. And the parentheses here just reconfirms that in order to have the exponent apply afterwards. So let's do the things on the inside in terms of simplifying them. So I am going to work over here for a second to make it easier to see why I'm doing certain numbers. I can see that for 15 and 6, they both have a common factor of 3, so I'll divide them both by 3 because that's equal to 1, so I can just divide it. And I get a negative 5 over 2. So I'm going to set this up with the parentheses. Here's the negative 5, and here's the 2. When I look at the x to the 10th, there are no other x's, so I'll leave that there. When I look at the y's, I have y to the 5th over y to the 3rd, and these 3 y's cancel out some of those. We'll subtract it to make y squared on top. Then we have these z's, z to the 0 over z to the 5th, but z to the 0, anything is equal to 1. Anything to the 0 is 1. So those 5 z's on the bottom, they stay there because there's no z's on top for them to cancel out. Now, our next thing will be to use that exponent with each thing, which means actually it was this thing here times itself. That means it's negative 5 to the 3rd power, x to the 10th 3 times, y squared 3 times, over 2 3 times, and z to the 5th 3 times, or to the 3rd power. And I'll come back up here to do more with it. Negative 125 is negative 5 times negative 5 times negative 5. And 10 times 3 gives us x to the 30th. And then we have y to the 6th. And underneath it, we have an 8 and z to the 15th. The only thing we have to deal with now is that negative needs to be in front of the entire thing. So our correct answer will be a fraction of negative 125 x to the 30th, y to the 6th, 8 z to the 15th. Now, having done that problem, there's one underneath it that's very, very, very similar to it. I want you to take a moment to do this one yourself. Pause the video, do it yourself, and then come back to it. And I will start it right immediately as you're back. Welcome back. Let's take a look at the insides of it. I have 25 over 15. I can divide both of those by a 5. So 25 over 15 is 25 divided by 5 is 5, and 15 divided by 5 is a 3. Okay, so that's what this is, divide by 5. 25 over 15 is 5 times 3, no, 5 times 5, and this one's 5 times 3, so these 5s cancel out. That's how I get the 5 over 3. And then x to the 12th, we have this x to the 7th, so we'll subtract 7 there, because 12 on top will be canceled out by 7 on the bottom. So we have an x to the 5th power. On this one, we have 1 on top and 9 on the bottom, so that 1 cancels out one of the y's that are on the bottom, so we have y to the 8th. Now we will apply the 4 to each thing, because that means 4 times we do each one of them. 5 times 5 times 5, x to the 5th times x to the 5th times x to the 5th times x to the 5th, 3 to the 4th power, and y to the 8th raised to the 4th power. Well, 5 to the 4th power is 625. Multiply 5 times 4 with the exponent. 3 to the 4th power is 81, and 8 times 4 is 32. Now, underneath it, or on the next page here, now we deal with negative exponents. You already have a little bit of from the things I've been doing before this, but now let's think about this. First, this is 1 times x to the negative 4th, and what I'm going to do is do 1 over x to the 4th, because the concept here is that x to the negative 4th goes to the bottom part of the fraction and becomes positive. Okay, move to other part of a fraction and change the sign. That is the key concept here, that you can move it, and you can move it to the top or you can move it to the bottom as long as you change the sign. So in this case, this x to the negative fourth was on top, so we now put it on the bottom, and that's the correct answer for this one here. Now look at the next one. We have a 3 on top. We're going to have a negative 4 exponent, so we bring it up to the top, but we change the sign. And that's really all you have to do. The 3 is not affected because that has a positive 1 exponent. So there's like no change for that. Now on the next one, oh, there's 2 negatives. I'm going to change both of them. I'll change this one, bring it up top, and I'll change then this one, bring it to the bottom. And there's nothing else I can do. There's no canceling to do, but I no longer have a negative exponent. The rules of math convention that is accepted throughout country and mostly pretty much throughout the world is you do not ever leave negative exponents in an answer. The only exception to that is if you're doing scientific notation, and there's a place where sometimes it's a part of a formula to use, but you'll deal with that, especially in a while. In logarithms is where you deal with some of that. But pretty much you just need to plan that you never have negative exponents except for scientific notation. Now in letter D here, I see lots of negatives. So the first thing I'm going to do is just simply switch them all to positives. I don't have to do that if I recognize some things about it, but I'm going to do that. These 2 bottom ones are negative, so they're going to come up to make them positive. And then the top ones here are going to go to the bottom. So now I'll do, on the top we have 9 of them, of the x's, and the 4 on the bottom will cancel out 4 of them, so there's 5 left. And the top of them, this one here cancels out some of the ones on the bottom, so it's 11 to the 8th power, or no, 11 minus 3 to make the 8th. Now, having said that, there's another way I could have done this. Oh, by the way, that is the correct answer here. Okay, now I'm going to do back to where I have x to the negative 4, like that, so it's very obvious, y to the negative 11, and underneath it, x to the negative 9, and y to the negative 3. Looking at this, I can decide to only move some of them because it will enable it to be a little easier. I'm going to take the smaller ones and move them. The larger ones. The larger ones and move them to the smaller ones. So I'm going to bring that one up. I think I'll use a little bit of space. Yeah, I can go over here for it there. So if I go x to the negative 4th and I bring that x to the negative 9 up, that becomes a positive 9. On the bottom, I have y to the negative 11th. Well, I can bring that to the bottom and make it positive 11, and here I have a negative 3, 1. So on the top now, I have a negative 4 plus 9, or a 9 minus 4. Well, 9 minus 4 is 5. 2 equals, here on top, 9 take away 4 is x to the 5th power. And on the bottom, 11 take away 3 is y to the 8th power. And so that means I'm only moving 2 of them to other parts of the fraction because I saw that if I do that, I can see subtracting right there instead of an extra step in between. Entirely up to you which way you'd like to do it as long as you get it correct. Now, in letter E, this one's very important. People tend to make a mistake about this one often. So make a note of yourself that this is important. And it's that the x to the negative 4th, that moves to the bottom of the fraction, but the 9 does not because the 9 has an exponent of 1. Not a negative 1, a positive 1. So the lesson here is that the negative 4 does not apply to the 9. So many times people do this and get the wrong answer of 1 over 9 x to the 4th, but that's wrong. Wrong. Okay, so make sure that you're aware of that so that you have a good understanding of of when you apply the negative, when you don't, with a negative exponent. Now, next thing here, letter F. Okay. I'm first going to clean up anything inside it if I can, and there isn't anything. So what I'm now going to have as my first step is apply the negative. And what I mean by that is that, watch what I write here in the middle. 4y to the fifth over 3x to the second. So notice there's a lesson here. I took that negative exponent and I used it to flip the inside of the parentheses. That's the easiest way to deal with a negative exponent for a large amount of things. By doing that, now this becomes 4 squared is 16. Y 5 times 2 is to the 10th. And 3 squared is 9. And then we have an x squared. And that's the correct answer for it. But now you need to see how I got that and recognize that what I did first was that I used the negative exponent there, and you just the negative part, not the squared part. Now, this also could have been done, okay, if I had done this part. In fact, I think that this arrow needs to come like this. So it would be okay if I did this. 3x, let's enlarge this so anybody can see it better. 3x, 4y to the fifth to negative 2. I could apply that negative 2 to each one of these. So it'd be 3 to the negative 2 power, x to the negative 2 power, 4 to the negative 2 power, and y to the fifth to the negative 2 power. Then I could have switched them all. Let's see, because that looks like a negative 9 there, but it's not negative 9 or something. I really have to then switch this. So I do 4 squared and 3 squared. And then that x to the negative 2 comes down as x squared. And this one was y to the negative 10th. So that comes up to be y to the positive 10th. Same answer. But dealing with so many of the negative exponents, why bother going through all that trouble? Instead, do this kind of thing where you switch, flip the top and bottom of the fractions. Get another chance to do that with this next one. But this next one requires first simplifying everything that's on the inside. So what I see is that the 20 over the 8 can be reduced to, let's see, 10 over 4 or 5 over 2. And then I'm going to bring some of those x's up here. So it's 7 take away 4, that's x to the third power. Okay. And then I see the y to the 8th. I'm going to bring this one down here as y to the negative 2. 8 take away 2. Let's make that a little clearer. 8 take away 2 is 6, so I have y to the 6th power here. And all of that to the negative 3. I'll apply the negative. Oh, so I'm putting the wrong ones on top now. So I have 5. Oops, I put it. That goes on the bottom. 5x to the third power. And on the top is 2y to the 6th. Now there is no negative exponent. Oh, there's not even a 6 either. It's supposed to be a 3. No negative exponent. So now I can apply the 3 exponent to each one of the things. 2 cubed, y to the 6 cubed, 5 cubed, x cubed, cubed. And so that gives us an 8, y to the 18th power. And on the bottom, 5 times 5 times 5 is 125. And we have x to the 9th power. There. Underneath all this now is a practice problem similar to the last one. Why don't you do that one yourself? Use the example if you need to right now. Pause the video and do that one yourself, and then come back to the video and I will work it out and you can see if you were correct. All right, go ahead and do that now. Welcome back. So I'm going to go underneath it here. And the first thing I'm going to do is to simplify these. So 5 into 25, 5 goes into 25 5 times, and 5 goes into 15 3 times. So I have a 5 on top and a 3 on bottom. Now the x's, I'm going to take these x's to the bottom. So what I have is x to the negative 7 and x to the positive 12 on the bottom. 12 take away 7 is 5, so it's x to the 5th on bottom. And then this can come up, so I have y and y to the 9th. Well, then that adds that 1 plus 9, so I get a y to the 10th to the negative 4th. Now I'm going to apply that negative, and that's going to make it 3x to the 5th over 5y to the 10th, and a positive 4. So 3 to the 4th power is 81. X to the 5th, 5 to the is 5 times 4, that's a 20. 5 to the 4th power is 625. And then the y to the 10th raised to the 4th power is 10 times 4, so it's y to the 40th. If you got that answer, you're in good shape with this. If you didn't, work back to figure out from what I put here what you did differently, and then start doing it this way so you can get it right. I hope that helps with dealing with these exponents dividing and when they're negative or when you're making them negative. Thank you for watching and listening.